peeps, Thiral here. This will be my video on making CTF challenges and making money from that. And this is a really great way to earn a few bucks, or I would say freelance in the cybersecurity field, because bug bounty is per my opinion, it's very luck based and you have to get lucky and everything. Here you don't, you make machines or CTF challenges, and because of your creativity, you get money from that. So basically, I will highlight the offensive securities user-generated content program. There are many other CTFs like Hack the Box. They also provide rewards for making CTF challenges for them. For offensive security, they only allow machines. So, for example, if you make a machine based on a CVE, that is a software which has a vulnerability publicly available, maybe an old software or something, you are eligible for up to $300 reward. If you make a custom web app, a custom privilege escalation vector, and basically have your own narrative without any kind of publicly available exploits or anything, you are eligible for up to $500 reward. And if you submit a grouped VM or chained VM, so for example, Active Directory environment, 3 or 4 Windows boxes connected with each other, and an attacker will have to pivot among them, that is eligible for up to $1,500 reward. So for this demonstration, I will show you the making of a $500 VM. This box will contain a completely custom build web application. That is, of course, except the HTML, as we will see later, and a custom made privilege escalation vector as well. And as this is just a demonstration box, I will have a very unrealistic or very common CTF kind of challenge here just for demonstration. So of course this won't work because offensive security, they need realistic machines, unlike something like Hack the Box where they need more puzzle-like or CTF kind of machines. So offensive security, again, they require realistic machines, so be careful of that. Any submissions on this user-generated content program will go to the Proving Grounds lab. So in Proving Grounds practice, I have my machine right here, rookie mistake I made. And again, it depends, of course. There is also Proving Grounds play as well and their own labs as well. They can do whatever they want with your machine, basically. So here, if we, this is the URL, by the way. So if we go down, you should read all this. So basically, they are saying that be creative, be original. Don't just copy something else that you saw on some other CTF challenge, and be aware of the security itself, even though you are making a vulnerable machine. Again, something very simple like a password for root is being Tor is not a good thing because that can lead to unintended souls for your machines. Now, this FAQ is very important. I have it right here. Please go through all this if you are planning to submit your own VM. They say everything regarding your host name, the flags where they should be, if you need firewall or anything. Everything is explained here, especially for the chained VMs and everything, if you are going for that. This is what I wanted you to see. So they have their own sample submission archive, which you can download. I don't really need to. This will be a zip, but I will explain it. So basically, all they want is these 3 things actually: a build guide made in Markdown format, a build.sh bash script, which will be the main script that gets executed on, you can say, building your own machine, and a walkthrough for your VM you have made. This is a data.zip file. Again, this has archive which has any data that you want on your VM, and we will go through that as well later on. But basically, this is the structure of the submission zip file that they want. Again, read all this. They have explanation for how to submit your own VM in the submission form. We will get to that. And yes, so another thing is, before you submit any machines, please register at the Discord for offensive security. So if you click here on this link, it's communityoffensivesecurity.com. It will redirect you to the Discord invite for offensive security. Register on Discord and then join here. And there will be a channel called UGC submission channel, something like that. And there you will be able to ask or get help regarding your submission or get updates regarding it. So here going through the form, of course, your first name, last name, the community username will be your Discord username after you join this server, and the Discord username and community username is the same. This is because I think a few months prior they had their own Slack channel or something, and that's why this link was different by then. And now they have just the Discord channel, so this both will be the same. Author of concept, that will be yes, because yes, you made this machine, you didn't steal it from anything else. And if you have submitted this machine to any other hacking or pen testing platform, so of course that will be no, we have not submitted it to any other CTFs. And of course, if you have submitted it, then there's no point in submitting it here as well, because that will be just a copy of that. Now this will be your community email address. This should be your primary address. And if you have given any exams like OSCP, then you will have received your OSID. That is basically your identification. If you don't have that, just type in 4 zeros. I think that's fine. Then your country, street address, city, phone number, and here comes the machine part. So your machine name, which will be anything you want, but make sure that it's not too simple, or it might be the same name someone else has used in their machine name. So make sure it's quite unique. Then the description. This again, don't spoil anything in it. So for example, in my machine, rookie mistake, sorry. The description is just beginner's luck. Very simple, quite not spoiling anything, just a simple description that what is in the machine, something like that. It doesn't really matter that much, but that should be. Then the submission archive, this we will get to. Basically, this zip file which contains these following files. We will get to that. Vector 1 and Vector 2. Vector 1 will be the first exploit, or I should say first security issue, which leads to command execution as a user. And Vector 2 will be the privilege escalation, which will escalate the privileges or access from the user to super user, that is root or administrator, depending upon the operating system you used for this VM. And then again, you will have to check that you read to agree the terms and conditions. This is basically that they are free to use your VM as they want. They can deploy it anywhere, and you can agree or disagree with the communications. You can check it or not. It's upon you, and then you can click on submit. So that's basically the submission form. After you submit it, after about a month or so, you will get a message on Discord uh, pinging your username which you entered over here. Here. So they will ping you and they will say if they have any kind of doubts regarding your machine or they want to change anything, they will tell you that on Discord. Or you might even receive an email regarding that. And after, let's say you have sold everything, let's say if they approve the machine, they really like the idea, they will send you an email regarding the approval. And that email will contain the bounty that you are eligible for, or that your machine is eligible for. So after all that, we can go to the machine. So, as per your machine, it will be either Windows or Linux. In Windows, you will have to download, I think, 5 GB ISO file from the Windows Microsoft official website, and you will have to install it and everything. For Linux, I use this Debian image, VirtualBox image. It will be automatically loaded, and it is a clean install. So I have it loaded over here. You will basically have to log in as the Debian user, and the password is Debian as well. I forgot ipconfig is installed. Basically, there will be nothing installed in here. Um, Basically, the login details are here. Username is Debian, password is Debian, and by default, it will have SSH open. So if I do SSH Debian at this IP address, which was 108, I think, and not 110, it will tell me to verify the fingerprint. Of course, we will say yes, and the password is Debian again. Oh, no, no. So yeah, that will log me in via the Kali box I have, and you can do it in your host OS as well. And this will be helpful in basically debugging the virtual machine that you are going to be submitting. Uh, so here, let me show you. Let me exit out of here. And this is the test submission that I am going to show. Basically, I have created one whole folder with just a machine name. This isn't the machine name, but this is just for this video. Then I have created three more folders here, one for privilege escalation, one is the web application, and the most important one, the submission itself. This again, if you have been paying attention, you might recognize this structure, which is the SIP structure that the offensive security needs for their submission. So let's look at the build script here first. Let's look at the web app first. Let me explain that first. So for web app, I have just got a simple HTML theme from this GitHub repository. Let me just open that. So I have just used this. You can use anything, and this is just for making your box more realistic. With having good design and good narrative, it will be more realistic. And I have done not really many changes. I have done just a few changes over here. In this last, I have just made a form here which will post to API eval, and we will see what that is now with this content. And again, of course, you will have to change all of this because this just feels very unrealistic. A company website with this text, lorem ipsum text. Basically, just have many more functionality like login and everything. Just for this demonstration, I don't have that much functionality in here. This is the main app.py. You can have PHP as well. I have done this using Flask and Python. You can have Node.js, anything you want. So for Flask, I have made a simple route to slash. So whenever someone visits this website, it will go to index.html, simple. Then from index.html, if it needs any CSS or images, like for example, this CSS and JavaScript, it will ask it from the assets directory, which is right here in the templates folder. I have made this route. Whenever it asks for the assets directory, the whole path it asks for will be given from this directory, templates assets. So in this folder, there is the templates folder and the assets folder, which has JavaScript and everything. Again, I just got this from here, this GitHub. There are many themes available on the internet. You can use any of that. So that's basically it. And this API eval thing that I made earlier, whenever it receives any post request, it will receive a parameter command from that, and it will basically just execute it. Very simple, of course, unrealistic. This is just for demonstration. And if the response is 0, if the ping command was successful, it will say our service is error, or it will just say we cannot reach ourselves. Simple joke. Now the main loop is the Flask app runs on this IP address. This means each and every interface, no matter what, a device from internet which can connect to this box will be able to connect to this service at port 8080. So that is our web application. That's simple. Our privilege escalation will be just a bash script. We will see what that does, and all it does is basically makes a tar gzip from which contains everything in the temp directory, and we will see what that actually does in a second. So now this is basically our idea or our content idea, this web application and this privilege escalation. Now we will make it into a virtual machine or I guess a submission for offensive security. So first we will have this build.sh script. This will echo out the box name. I'll just put it test box and the author name Tira. And if it is a Windows box, just put Windows here. First, we'll do a simple apt update. Then we will install Python 3, Python 3 pip for installing Flask, netget, which can be used for getting a reverse shell, the password utility, which we will use for adding a password for the users, curl, bash, anything, unzip, very simple things, because again, as I said earlier, the Debian box is very light. It doesn't contain anything. You will have to install everything by yourself. And this is again a great way. So for example, if the Debian box came with Python and I forgot it over here, during my test environment, the VM will work fine. But on offensive security side, that might not be the case because they haven't installed Python here because it wasn't mentioned in the build script. And again, this script will be running as root. So now we will set up the host name. And this again, sorry, I forgot earlier. This build script and all this markdown is from the sample submission, which we saw earlier. I just copied it and made some changes like the hostname here. You can find it over there. You don't need to create this whole thing by yourself. Just make a few changes in the default build script and walkthrough and the guide. So yeah, we'll make the hostname test box. Then we will create a low privilege user. I just called him test user. And this is just from the sample submission. It basically creates this user. Then we will set passwords. This is again important. Make sure the passwords aren't too complex to copy. They should just be simply just words with followed by a few random numbers, and that should be enough. No need to have some special characters or anything. No need for that. Then we will unzip the data.zip. Data.zip is basically file. So from this command, recursively zipping the everything inside the web app directory and previous directory will be in data.zip. That's all that is. So unzipping that, we will have the web app directory here and the privilege escalation directory as well, right here, which we will utilize. So on the on the VM, we will move the web app directory in the home test user which we just created, and we will make sure the test user owns the everything inside the web directory, and then we will make a service out of it. So service in Linux allows us to always have the web application up and running whenever the system is restarted or any error is encountered, anything it crashes or something. So this base64 is just encoded content of this. Basically, all it is a service with the description of the web app, and all it does is, as the test user, uh, it will on this working directory of web app, it will execute the app.py using Python whenever it is restarted. So make sure this is on, because if the service doesn't restart and if someone just simply crashes or restarts the box, it will just not start again, and that will just break the entire virtual box. Then we will simply reload the daemon and enable our service we created and restart it as well, just in case. Then that was the web app. Now we will set up the privilege escalation. We will just move the bash script which we saw earlier, this thing, in user bin, and then we will make sure the permissions are so that uh, everyone else can read it and the owner can only execute it. The owner will be root because this script is run as root, and everything else will be our test user. He can only read it, he will not be able to execute it. However, in the sudoers file, which means basically whenever the test user does sudo -l, we will see that later, he is able to execute without giving any kind of password. This sh script is root, all means any user, and of course that will be root by default. Next thing we do is we make sure that there is no bash history. So all we did here should not be in the history. We will just link it to dev null. So whoever tries to read the bash history, they won't get anything. Next, we will drop the flags. These are proof basically that you have to submit that make sure that you properly got access to this user or as root on this VM. And I just use this website for sorry. Yeah, I just use this simple website which creates random MD5 hashes, and those 32 character hashes should be enough as flags. We make sure to set the permissions so only root can, or the owner, which will be the root here, can read the root flag, and the owner here can, or anyone else can read the local.txt, which is the user flag. In other CTFs like hack the box, it will be root.txt and user.txt. So make sure you're accordingly changing that. And again, we make the owner of this local flag the test user. So anyone who has command execution as the test user will be able to read this user.txt or local.txt flag. Finally, we clean up all the caches and I guess history files and everything. So we also clean up the data.zip, the privilege escalation folder, and the build.sh script itself, so that whenever a user gets full root access, they don't want any artifacts for making this VM. Lastly, this find var log thing makes sure that every log inside var log has the dev null inside it. Basically, it is emptied out all the logs in var log. So that's our build script. This will be executed. on the VM, as you will see now. Then we have this build-guide.md. This makes sure that you are correctly building the VM. This contains information regarding your idea basically. So again, your box name, the author name. If you need the firewall or IPv6 support or antivirus or anything, you can accordingly change this. We need the Linux box, so Ubuntu is fine. Host name which we had here, just paste it here. Vulnerability 1 will be the vulnerability in our web app, which we saw this one executing command. So we can just call it command execution. And vulnerability 2 will be wildcard injection, which is this wildcard. We will see what that is later. Uh, so that will be that. Then your root password and user password, which we entered here. Make sure to change it on every box and make sure it's pretty unique, not very simple. Then again, location of local.txt and location of proof.txt, which we saw here. Next, we have the settings. So this is just the default one. 2 CPUs and 2 GBs of memory should be enough. 10 GBs of disk will be enough. And then we have instructions. So of course, we will install the Linux box. This is followed by offensive security. So make sure that everything is correct here. Enable networking, and we will update and upgrade the whole box. Then we will upload the following files: the build.sh script and the data.zip, which contains the web app and privilege escalation folders, which are required by the build.sh. And then we will just execute the build.sh to make our own VM. So if your script needs to have restarts or anything, you can just mention it here that of course we should restart and then run another uh, build2.sh if you require that. Usually Windows requires it, Linux doesn't. So yeah, uh, and then we have our walkthrough. So going through this, I'll just show how to debug or set up your own VM for testing. So I have this Debian box, as I mentioned earlier. I SSH'd in, and now I need the build.sh and data.zip here as root. So what I'll do is exit out of this. I will use SCP to copy the build.sh and data.zip over to this box in the temp directory. This isn't the IP address. So again, give Debian as the password, and now it is transferred over to this box. And now I need to execute them as root. So I will become root by saying sudo bash. And now I'm root. I will just go to /root because again, build.guide mentions going to /root. We'll have to upload both files over here and then execute them. So I will just move those two files from temp. And now I can use bash to execute build.sh. Now, of course, because this is updating and upgrading, so it will take a little time. Our box doesn't contain too many applications or anything, not too many installs, so it should be relatively quicker. So one thing, I had a problem here. I actually had the capitalization here, which was a problem, so I had to rebuild the whole script. And another thing I wanted to mention is don't have these comments in the actual build script. This is just for my demonstration. Just delete them. Delete the one with the random MD5 hash URL. I just included it for demonstration. Just the comments on the sample build.sh script. I think it's just this one. Just keep it there. Don't have any other comments. No need of that. And basically, after it completing, you will have our box ready. And this is just for debugging or I guess checking if our idea is completely working or not. Let's just do a simple nmap, and now it says 8080 and 22 is open. Now SSH is by default installed in the Debian box, but we haven't enabled it on our build script, so just ignore that. For us, only port 8080 should be there. So whenever the offensive security guys do that, they will only have 8080 here, ideally, unless they want SSH as well. So now we can go to that website. And here's the template that I used. Let it load. So yeah, this was the template again. You should ideally just change not everything, but just a few things so it looks realistic. Maybe have a few more features like login functionality or filtering in the check command everything. And if you're making for example, a CVE box for 300 reward, you will have, instead of all these folders, you can just install, or I should say, where is it? So for example, in this web app, if you just wanted a CVE here, you will just duplicate, download any old application and install it. That's it. You don't need to install or have a web application or anything. Or yeah, basically you don't need to create custom things. And of course, you will get less reward for that. Uh, so of course, in the walkthrough, first we will mention the lessons learned. So here we will have command section, getting a reverse shell, then pseudoers, rule enumeration, wildcard injection. We will see all that in a few seconds. So first thing we did was run an nmap scan. So it will reveal that only port 88 is open. Again, port 22 is by default installed on the Debian box, so we are not counting that. On the web application, let's see this check button, what this does. So let me just open up burp suite. So burp suite is open. We can go to proxy, make sure intercept is on. But before we do that, let's see what this check actually does. Pressing it, let's see what it does. So it says our services are up and it goes to API URL just like we programmed it to. So let's intercept the request this time. I have made the Foxy proxy go to burp proxy. So again, we will click on check and burp intercepts the request. We can send it to the repeater and we can turn off the interceptor. Now we do not need that anymore. So in the repeater, we can clearly see a command here, and again, we can just put our own command. So we will get a reverse shell using netcat here. So let me just get my own IP address here. Oh, my bad, this isn't Windows. And then I will start a listener on port 443. Because this is a lower level port, I need the sudo or root permissions. And this is my IP address. So this is basically what the attacker or student will do to your box whenever it gets approved and uploaded to the lab environment. We set our port to 443 and we will execute the bash when we connect. So let's send it and we got a connection back. So as the test user. So let's mention it on our walkthrough. So again, what we did was we saw the post request to API evolve and it had this command by default is this value. We changed it to a netcat, simple netcat reverse shell, and we got a reverse shell as the user. So now we can just beautify this terminal, this reverse shell. So now we have this pretty little username and current directory printed every time, and we can just read the user flag via this command. So basically the importance of walkthrough is make sure you are clear on each and every step and make sure you include input and output both. No need to include the output of this local.txt of course, but you should include output for like say this nmap scan we did and anything else we will be doing. So now as this user we can see our sudoers rule and we can see as this user he can execute without giving a password this bash script. And because of our permissions here, right here, anyone can read this bash script, but only the root or the owner can execute it. But because we can execute uh, this script as root, we will be able to, well, execute it. So let's first see what that is. Of course, we know that the attacker won't. So they will get it and just forget there's no new line here. So this is where it ends, basically. It is a simple script which goes to temp directory and gzips all the files there to backup.tgz. And here, this wildcard means bash will have each and every file present in the temp directory, just pasted here their file names. So we can take advantage of that. Tar also has some arguments. So if I do, if I do tar help, we can see this. There are so many arguments we can make use of. These arguments we can have as file names, and bash will just put file names here and tar will think it is an argument. So in the walkthrough I included this URL. So let's see if we can go there. So yeah, make sure you include as many references as possible for whatever exploits or vectors you are using. So here they mention again, this is a very common CTF challenge. Of course, be sure to have some creativity and make sure to have different kinds of challenges here, but this is just a very common one for demonstration. We can exploit this wildcard using these commands. Basically, all they do is make a file with a file name this, and this again, bash will interpret it as the argument for tar command, and it will execute our shell.sh, which we will make here. So again, in the walkthrough, I have said that do these steps to gain root privileges. All we do is go to the temp directory. Sorry. Then we will echo this reverse shell again, the same one we used, into a shell.sh script. Okay, just paste it here and make sure to have a listener ready. And also, ideally, we should check the IP address as well. Make sure it's the same. Oh, it isn't. So let me change that. So again, these IP addresses don't matter that much because we are doing this on our own network on our demo, but it still is pretty valid. You can just type in attacker IP over here and it will just be the same. They just need to know what there should be here. Then this creating a file name and this file. So this is just a basic tar exploit, not even an exploit. This is just how tar works. If we have a checkpoint equals 1, it will execute any command mentioned here in the checkpoint action parameter, and which is just executing shell.sh, which contains our payload for reverse shell. So our listener is ready. Now we can just execute the sudo shell again, and we can execute this bash script as root. And we get a connection back, and now we are root. So we have compromised this machine. Now we can just get the root flag and mention it as well here. So this is it. This is our box. This is our submission, and this is our idea. We debugged it using the Debian box, so we know everything works perfectly. Everything works fine. And again, I had a hiccup over here. I accidentally had the username incorrect with capitalization. So again, debugging helps. If I had just submitted this without debugging it in the Debian box, there would have been problem. I would have had to submit it again, and it would have wasted time for everyone. So make sure the script and everything is properly working, and make sure or double or triple check it so there are no errors or anything. And once you have everything ready, that is the build guide, build script, the data.zip containing any kind of data that the build script uses, and the walkthrough. Again, in the walkthrough, they require the MITRE map, which is very simple. If you go to the MITRE's website, attack.mitre.org, let it load. So here it is the map, and basically all you have to do is, so for example, we did the nmap scan, so active scanning is here, which is the first one here in reconnaissance. So we scan the target, so mention it over here, T1595 here. Then we exploited a web application, so exploit public facing application. And again, if your box contains anything else like default credentials or something, it will be invalid account. Let's say WinRM open in the Windows box, then external remote services, stuff like that. This you have to map out. It's very simple. Just read through it and you will get an idea. And that was basically it. Now for the actual submission. Let me exit out of the Debian box. So now we have all these files that we need to submit. So we'll do a zip, the build guide, the build script, the data, and walkthrough. And we will call it your box name.zip. So I'll just call it test box. That's it. Oh, my bad. Testbox.zip comes earlier. And then our build guide, our build.sh, and data and walkthrough. And so now we have this testbox.zip, which contains everything. And this is the zip that we have to submit on the submission form. And that was basically it. After doing this about around a month, you will get a reply of either approval, or if they don't like any idea, they want to change it, you have to do that. Finally, a few tips. So make sure that the narrative and the machine itself is very realistic. For example, if you are making a vulnerable machine on e-commerce website, then make sure it has a logging functionality, it has a cart, or the main security issue is based around something you find in an e-commerce website. And if you have any kind of questions during this process, you can feel free to reach out to any student admin or any people in the Discord channel I mentioned. Few CTFs, even a few machines in offensive security might require you to upload the OVA format, which is just exporting the vulnerable machine we built. So for example, the Debian box we built using our build script, and it will be in sizes of GBs. So that's why I prefer just submitting the build script instead of an OVA. The build script is only a few kilobytes. And finally, this video was made for students who are more than capable for many certifications or exams but cannot do it because of their financial situation. So this is a great way of earning money for those exams or certificates. Of course, there is bug bounty as well, but again, in my opinion, it's very luck based and it's very inconsistent. Here you can build your own boxes, your own narrative, your own ideas. You don't need luck for that. Of course, this requires a few months to review and get everything in process. So that was basically it. Thank you so much for watching this video, and I will see you all next time.